Hello and welcome. Today we are going to discuss the sampling techniques. Our agenda here will be this definition of sample, target population, probability sampling techniques. In the next session, I will discuss this non-probability sampling technique. As we'll start by defining sample. A sample is a finite number of an item or an individual taken from a population having identical characteristics with those of the population from which it is drawn. So a sample is considered biased if one or several of the items or individuals in the population are given consistently better opportunity to be chosen than the other. So size of the sample or sample size depends on several factors. Some of these are the degree of accuracy required to determine the sample size, amount of variability inherent in the population from which the sample is taken, and nature and complexity of characteristics of the population of the study. So there are also keys to good sampling. Formulating the aim. So sample size or sampling technique is dependent upon the aim or objective of the study. Decide what analysis is required to satisfy these aims, deciding what data are required to facilitate analysis. Collect data required by the study. So sampling strategy or survey sampling method, one of the key characteristics of this sampling strategy is defining target population. We define target population based on logic and judgment or argument, based on empirical or theoretical perspectives. If the entire population will be sufficiently small, then we take the entire population in the study. This is called census study. Sometimes the entire population may be small. In that case, we can take the whole population as our sample for our study, and we call this census study because we gather the data on every member of the population. But most of the time, the population will be too large for researchers to attempt to survey all of its members. In that case, we take a carefully chosen or a carefully selected sample to represent the population using different sampling techniques. So the sample reflects characteristics of the population in the case of large population size. So sampling techniques are classified either into as probability or non-probability. In probability sampling, each member of the population has non-zero probability of being selected. So there is some chance of being selected in the case of this probability sampling technique. Probability sampling techniques or methods include simple random sampling, systematic sampling, stratified sampling, multistage sampling, different cluster sampling. There are different sampling techniques, probability sampling techniques. In non-probability sampling, members are chosen from the population in some non-random manner. This includes convenience sampling, judgment sampling, quota sampling, snowball sampling. The advantage of probability sampling is that the sampling error can be calculated. We can calculate the sampling error. The sampling error is simply the degree to which a sample may differ from the population. The discrepancy between population parameter and sample characteristics. When inferring the population, results are reported plus or minus the sampling error. So in non-probability sampling, the degree to which this sample differs from the population remains unknown. We do not know for sure the difference between population parameter and sample parameter. So we are going to discuss the first type of this broad category of sampling technique, that is probability sampling technique or probability sampling method. Simple random sampling involves making a list of the population from which the sample of respondents or people that will be interviewed is selected. An example is a group of 100 individuals are listed, and a group of 20 may be selected from this list at random. So the selection may be done by computer or these random generated numbers or random table number or by hand using lottery method. So each member of the population has an equally known chance of being selected. When there are very large populations, it is often difficult or impossible to identify each member of the population. So the pool of available subjects becomes biased. So random sampling means that each individual in the population of interest has an equal chance of selection. So sources, for instance, telephone book or voter registration lists are not adequate for providing random samples of the community because the sources are biased, because there may be some people, some persons or some individuals with no phone number. So bias sampling bias may result because the population, the sample included the part of the population that are included in the study, and those parts of the population that were not included in the study creates discrepancy. So telephone surveys get around this problem by random digit dialing, but that assumes that everyone in the population has a telephone because there may be certain members of that population that has no telephone. The key to random selection is that there is no bias involved in selection of the sample, and there is also a non-zero chance of being selected. Any variation between sample characteristics and population parameter is a matter of chance. Therefore, if there is more heterogeneity among the units of the population, a simple random sampling may not necessarily represent the characteristics of that population. Therefore, there should not be this heterogeneity. For us to use simple random sampling, the population must be homogeneous. So simple random sampling is not used for heterogeneous population. If the unit of the population are heterogeneous, we cannot use the simple random sampling because simple random sampling assumes that the population is homogeneous. ሆሞጂኒየስ የምንለው ተመሳሳይ ከሆነ ነው ሲምፕል ራንደም ሳምፕሊንግ የምንጠቀመው እንጂ ሄትሮጂኒየስ ከሆነ አንጠቀምም። ወደ ስትራቲፋይድ ሳምፕሊንግ ነው የምንሄደው። እሱን ቀጣይ እናየዋለን። So the second one is systematic sampling or nth name selection technique. This involves drawing up a list of potential respondents and then selecting respondents from the list. For instance, every fifth person on a list will be selected as a respondent. So that would be the fifth, the 10th, the 15th, and the 20th person. So first we select the first unit and then we select based on that size, interval or size. After the required sample size has been calculated, for instance, every nth record is selected from the list of the population. የመጀመሪያውን ለምሳሌ አምስተኛውን ብንመርጥ አምስት ከሆነ ኢንተርቫላችን አምስት ሲደመር አምስት 10 10 15 ከዛ 20 እያልን እንቀጥላለን ማለት ነው። So as long as the list does not contain any hidden order, this sampling method is as good as random sampling method. Hidden order የምንለው ምንድነው? አንዳንድ ጊዜ ሰነፍ ተማሪዎች አንድ አካባቢ ሊስት ላይ ሊሆን ይችላሉ። ያንን ማሰብ መቻል አለብን። Its only advantage over random sampling is its simplicity. It's frequently used to select specified number of records from computer file. So the number k is so chosen in such a way that n times k equals to n or is just less than n. An example is, suppose that there is a list of 100 participants or schools from which a systematic sample of n7 schools is selected. There are 100 schools, and we have to select 7 schools. The researcher may select one school at random from 14 schools of the list as a point of departure. So 7 times 14 is equal to 98. It's less than 100. So our interval is, for instance, this 14. If the school at serial number 6 is randomly selected from the first 14 schools, then the researcher shall subsequently select every 14th school, because 7 times 14 is 98, less than 100, until the list is exhausted. 7 ትምህርት ቤት ነው የምንወስደው። ስለዚህ 7 ሲባዛ በ14 98 ነው፣ ከመቶ በታች ነው። ከዛ የመጀመሪያውን 6 ቢሆን ከ6 ጀምሮ በየ14ኛው ኢንተርቫል 7 ስኩል እስክናገኝ ድረስ እንመርጣለን ማለት ነው። So accordingly, school starts this number, for instance, 6, 20, 6 plus 14, 20, 20 plus 14, 34, 90 are selected. 1, 2, 3, 4, 5, 6, 7 elements or schools will constitute the systematic sample in our present case. Therefore, we also select the final subjects from these schools. This is systematic sampling. So the third one is this stratified sampling, used when population has heterogeneous groups or strata and homogeneity within groups. It is a random sampling method where you divide members of a population to strata or homogeneous subgroups, or for instance, religion, Orthodox, Christian, gender, male, female. So this kind of stratification, stratified population. So we use this stratified sampling when the population has heterogeneous groups or strata and homogeneity within the group. Homogeneity within the group ስንል ሴቶች አሁን ተመሳሳይ ናቸው። Across the group ግን ሴትና ወንድ ይለያያሉ። So if the different if it is different from other types of sampling technique because you are separating the population to groups first. You must be very familiar with demographics of your population if you intend on using stratified sampling. Assume that you want to study the effects of religion on attitude of students toward studying science and elementary, junior, secondary, and senior secondary schools in Addis Ababa. So before sampling, the population will be divided into characteristics of importance of research, for instance, by gender, social class, education level, etc. Then participant is randomly selected within each category or strata. If 38% of the population is college educated from our population or university, then we select 38% of the sample is randomly selected from college education population. So these stratified samples are as good as or better than random samples, but they require very detailed advanced knowledge of heterogeneity of the population between groups and homogeneity of participants within the group. When dividing stratified sampling into stratified random samples, we must consider that there is no crossover. There is no crossover among samples. The stratified random samples must include all members of the population. So stratified random sampling is more appropriate under the following conditions. When the list of units of individual in the population are not available, list ሳይኖረን ሲቀር ነው አንደኛው። When it's extremely heterogeneous, so when the population list is composed of extremely heterogeneous set of items, this is between group ልዩነት ሲኖር ማለት ለምሳሌ ወንድና ሴት፣ ኦርቶዶክስ፣ ፕሮቴስታንት፣ ሙስሊም። When required responses have to be cross-tabulated by such factors as sex, educational background, socioeconomic status, and so on. When stratification results in greater homogeneity within the strata with respect to the trait under study. So the fourth one is this cluster sampling. When groups are homogeneous between and heterogeneous within, we use this cluster sampling. So it is the opposite of stratified sampling. Homogeneous homogeneous for strata, we use stratified sampling when there is heterogeneity between groups and homogeneity within the group. But we use this cluster sampling when there is homogeneous characteristics between the groups and heterogeneous characteristics within the group. So cluster sampling is the sampling method where different groups within a population are used as a sample. So this is different from stratified sampling is that you will use the entire group or cluster as a sample rather than randomly selected. Remember that we randomly select from stratified samples in the case of stratified sampling technique. But in the case of cluster sampling, we only take the whole cluster. And the whole cluster is simply heterogeneous, not homogeneous. So when conducting research using cluster sampling technique, we keep a few things in mind. For instance, cluster random samples cannot have crossovers. And cluster random samples must include all members of the population. So cluster samples must include all members of the population, meaning that all students in the school must be a member of one of the four clubs. That means cluster samples are miniatures of the population. If there are students that are not members of the club, then the cluster samples does not work. So one cluster must not be unique. You should use cluster sampling when the entire population is unclear or unknown or infinite. The sample clusters are geographically component. The clusters are natural in a population. And when list of units of the population does not exist, when geographic distribution is scattered, or when sampling of individual units is not convenient for several reasons. Sometimes, for instance, you will not have entire list of the members of the population. In that case, you can use cluster sampling. In this case, you can use this cluster sampling to collect information from the group in the population. You may not have lists. If you require establishing norms for the 8th grade national exam for Oromia regional state, it may not be feasible for you to collect a simple random sampling of students in the state because it's possible to sample students or groups of such children. So taking a sample of students from among the school population in Oromia regional state, the school population cannot be completely listed. Hence, all A's class children in the state may be sampled in groups or in clusters from woredas, from specified woreda or zone. So the last one is this multi-stage sampling. So in multi-stage sampling, we take respondents through the process of defined stages, stage 1, 2, 3. Residents, for instance, within London, Slington may have been chosen for a survey through the following stages. First, we select UK. From UK, we select Southeast. Then from Southeast, we select London. From London, we select Slington. So this is stage 3. And stage 4, we select polling districts or woredas from this Slington. And then stage 5, we select individuals. So as we have demonstrated, 5 stages were gone through before final selection of respondents or participants in this kind of sampling technique. Thank you for your attention.